with special guest Elizabeth Dunning to do a 2011 AP Calc problem. How are you doing today, Elizabeth?
I'm doing great. How about yourself?
Doing excellent. This seems like an episode of Throwback Thursday. We're going to do part A of this function problem, and one of the reasons why this one is so important to look at is there's a whole bunch of different graphs that you can see and they ask you about. You always want to keep track of what you're really looking for. Kind of focus in on that. So I'm going to read all these words teenagers don't want to hear. The continuous function f, it's obviously continuous because there's no breaks in it, is defined on the interval -4 to 3. The graph consists of 2 quarter circles. I see one of them right here. I see another one right here. I don't necessarily need to fill them in, but they're probably asking about the area of those. They wouldn't give me that info if they weren't going to. And one line segment, as shown in the figure above, g of x equals 2x plus the integral from 0 to x f of t dt. You done? I'm looking at this part right here. What do you think that's going to end up being when we get to it?
Drop the top.
It's probably going to be a drop the top problem. Half of it's probably going to be asking me to find area, because that's what the integral does, and the other half's probably going to be drop the top. So the first thing they asked me to find is g prime of 3. So I'm just going to fill the numbers on, and then it's not g prime of 3. Peter messed that up on me before.
The first thing they ask you to find is g.
Right, Peter, this was Peter. Peter, come on, buddy. Peter just was peeking in the door, making us laugh. We're going to find g of -3, and we're just going to fill that -3 in, so that means we're going to find 2 times -3 plus the integral from 0 to -3 f of t dt. So now we have these negative signs in there, right? Let's see if we can find our correct answers. What is 2 times -3?
It is -6.
Excellent. -6. And now let's look at the next part. They're asking me to find the area under the curve. Starting at 0, we can mark it.
0.
Going to -3.
To -3. That's right.
Right there.
Here. So the area of this
Right.
bad boy.
And so what I always do is I just find the areas first and deal with the signs later on. That's obviously a quarter of a circle, and the radius is 3. So if it was a regular circle, it would be the area pi r squared, which would be 9 pi.
So it's.
But it's a quarter circle,
1/4.
so it's 9/4 pi.
Okay.
And I'm not going to combine anything, there's no reason to. Or 9 pi over 4. And now I'm just going to check whether that number is positive or negative. I disagree with your positive sign.
No.
Because my integral is going from 0, and it's going to -3. So I'm going in this direction. That's why we always deal with it afterwards. You can always go back and check it later on. The area is positive up top, but the direction is negative, so this sign would have to be a negative sign. As you think about it in terms of divide this into rectangles, this side is positive, this side is negative, so it's going to be a negative answer because of the direction we're going in. Okay, the next part asks me to find g prime of x. Can we find g prime of x?
We can.
So we have to take the derivative of this statement right here, and we have a nice drop the top problem. We're going to like that. So it's going to be g of prime of x equals derivative of 2x.
2.
2 plus, just going to drop that top right on in, f
of
x. All right, got our answer right there. So the last thing they asked me to find, you can write it over there again. G prime.
G prime of -3.
Yep.
So we have 2 plus f of -3. And come over to the graph and find f of -3, which is 0. So it's g prime of -3 equals 2 plus 0. Mr. Brigham, what's 2 plus 0?
I don't know if common core change. I think it's still 2. Yeah, it's 2. It hasn't changed.
Yeah.
G is 2. And she did a really good job there of knowing that when they asked about f of -3, if you're not necessarily sure where to go, always go back to the start. This graph is of f. So you're putting -3 into that f graph, even with all the other stuff on there. You done an excellent job. We're going to continue this other problem tomorrow.